Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So this is the second recording for this video. So I think we just go quickly. So besides of the methods of analysis, which is the nodal and mesh analysis, we have also several theorems that we can use to simplify or to assist in the circuit analysis. Okay, so we have here the superposition theorem, which will be covered in this video. Okay, and next will be next week video, which is I think before we go to this Thevenin and Norton, so I would like to introduce you about the source transformation. Okay, because Thevenin and Norton is actually quite identical to the to the source transformation theorem. Okay, so what is the theorem is all about? So it states that the voltage across or the current that go through an element in a linear circuit is the algebraic sum of the voltage across or the current through that element due to the each independent source acting alone. Meaning that if you have a circuit that contains two sources, okay, so you need to only turn on the other source while the other source is need to be turned off. So what is mean by turn off? So it depends on the sources. So if the voltage source, so you need to set it as a short circuit where it is actually the voltage source is equal to 0 volt. And if the source is a current source, you need to open circuit the current source so that the current source has a 0 values. The dependent source, which is not covered in the syllabus, so you can ignore this statement. So step to apply the superposition principle. So the first step, what you need to do is to turn off all independent source except the one source only. Okay, and then find the output or the output voltage or the current that you are required to find due to the AC source using nodal or mesh analysis. You need to repeat the first step for each other independent source. And then after you complete all the sources, so the voltage and current, the output voltage and the current that you need to find is actually the summation of all the contribution due to the independent source. However, the technique do not allow us to find the power at any separate circuit. Okay, so usually the power and absorbed or supplied by each element can be obtained from the final results, which is the contribution. Okay, and the last statement here shows the advantage of using this superposition theorem. The most advantage of using this theorem is when the source contains a mixture of sources. For example, you have a DC source and also an AC source in a single circuit. Okay, so you cannot directly calculate the circuit. If you have this type of circuit, you cannot directly calculate using mesh and nodal because the properties is quite different. The DC source is zero frequency, while the AC source, they got a frequency value, for example, 550 hertz. So it's quite different. So you need to use the superposition theorem to obtain the final value of the output voltage or the output current that you are required to find. For example, okay, this is a circuit that contains two sources, but this is actually a DC source. You have a voltage source and you have a DC current source. So by applying the superposition theorem, so for example, to get this voltage, you need to turn off either source. Okay, for example, since this circuit has two sources, so meaning that you have two different circuits. The first circuit is the circuit where you turn on the voltage source, and the second circuit is where you turn on the current source. Please be noted that for the first circuit where you turn on the voltage source, the current source is actually open circuit. And for the second circuit here, where you turn off the voltage source, so the voltage source will become short circuit. Okay, so the voltage that due to this, for example, this circuit, the first circuit, so you will obtain the voltage across 4 amperes that due to this contribution of the 6 volt. So we define it as a V1, or sometimes in other nodes is actually V prime. Okay, V prime. So I need to annotate first. Okay, draw. Okay, so sometimes it's also V prime. The second circuit, as you can see, is the V. You will obtain the V2. This V2 is actually the voltage drop across 4 ohm that due to the contribution of the current source. So sometimes also V double prime. So the total voltage here is the summation of contribution of a single source here. Okay, the contribution V prime is due to the contribution of the 6 volt, and the V double prime is due to the voltage drop due to the current source. Okay, and then after that, the power can be calculated, for example, V square over resistor. So you cannot use V to get power V prime over R plus V double prime over R. So this one is totally wrong. Okay. Okay, so next is actually the examples. So this is examples. Actually, in my previous video, I have already what you call do it online. But since we have some problems on the video itself, so I just we call show you the solution. Okay. Okay. So we have two different sources. So let's turn off the current source first. So when you turn off the current source, it will become open circuit. So the circuit will become like this. So the voltage across 2 ohms is the voltage drop due to the 12 volt. So as you can see, this one are in series. So you can just use a voltage division technique. So my VO prime is 12 over 5 volts. Okay. And next is actually we turn off this voltage source. When we turn off the voltage source, it becomes short circuit. Okay. So the circuit is will become like this, and this is VO double prime, meaning that this is the voltage drop due to this 5 amperes. So as you can see right now, this one is actually you can use a current division technique to obtain I1. Okay. So I1 is equal to 5 over 2 amperes. After you obtain I1, then you can just multiply with the resistor 2 ohms to get the voltage drop. So the voltage drop here is 5 volt. So the total voltage due to this both voltage and current source is the summation. So 12 over 5 plus 25 over 5, which is 37 over 5 volt. Okay, the second example. Okay, so this is the second example of the superposition theorem. As you can see, we have three sources, meaning that you need to do it repeatedly three times uh, for the same circuit. Okay, so first of all, so I turn off the others two, 24 volt and 3 amps, so it will become, the circuit will become like this. So short circuit and the current source is open circuit. So right now, as you can see, the circuit can be simplified. Okay, plus, but make sure that the information about the current is not disappeared. Okay, so since this is I1 prime here, so still in the same position, I1 prime. So you only simplified the other reference, the other resistor. So 8 series with 4 and parallel with 4. So you become 3 ohms. Okay, so from that, the circuit is actually a series circuit. So you will obtain the I prime is 2 amperes. The second one is actually I turn off 12 volt and also turn off the 3 ampere source. So the circuit will be become like this. And I simplify. So, but since this one cannot be, if I didn't simplify the circuit, I will not obtain the I1 here. So I need to simplify first, okay, to obtain the current, the total current or the voltage. Okay, so as you can see here, I obtain this circuit 8 is in series with 4. And 4 are actually in parallel with 3 ohms here. But the voltage across this, since this is parallel, so the voltage across this is actually similar. So if I parallel this one, I will obtain the equivalent resistance is 12/7. But the voltage is actually will be the same. Okay, so I need to calculate what is the voltage across this parallel resistor here. So after, by using the voltage division technique, so I will obtain that my voltage across this parallel circuit, this parallel resistor here is 3 volts. Okay, so after I obtain my 3 volt here, so I expand back the circuit, okay, like this. So since this is 3 volt, this is also must be 3 volt. So the current that I can get here is I double prime. Okay, so since the direction of the current is entering the negative terminal, so this one will become negative V over R. So I will obtain negative 1 amperes. And the last one is actually we turn off the other voltage source and we turn on the current source. So this circuit looks like a very complicated circuit, but if you look carefully, it can be simplified. So I color the node here just to make the simplification much easier to be understand. Okay, so as you can see here, this node and this node are actually the same. Okay, so actually I can reduce this root of the wire here. Okay, so I will actually get this circuit. Okay, and as you can see, 4 and 3 ohms here are actually in parallel because it shares 2 nodes, the green node and the blue nodes. Okay, but the voltage is still the same, Vx here. Okay, so from here you can see that it is parallel. So 4 is series with 1.7 and this series is actually parallel with 8 ohms. So we can obtain I1 by using current division technique. So it become 1.75. Okay, so after that we obtain the Vx, which is equals to 3 volt. Okay, and then my current is actually 3 volt over 3 ohms, so we have 1 amperes. And the total current due to these three sources is the summation of I prime, I double prime, and I triple prime. So I will obtain 2 amperes. And the power that dissipated by this resistor is I square R, which is 12 watt. So I think that's all for the superposition theorem. Thank you very much.